Hi, this is Bobak. In this video, I'm going to solve the following problem for you. This is a problem in linear algebra on the topic of lines and planes in 3 space. Let me read the problem for you first. Consider the point A with coordinates 2, 0, and 1 on the line L with equation x equals to y equals to z, the canonical equation of my line. Determine parametric equations of a line that passes through A and intersects L at right angle. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, the answer that you might get is this answer that I have written here. The reason I am saying that this is the answer that you might get because you can have different forms which is still correct. Okay? So, let me solve the problem now. I would sketch some figure for myself to understand the problem better. Okay? So let us assume that this line is line L here. Yes? This is my line L. And I have a point A with coordinates 2, 0, and 1. Because the coordinates does not satisfy the equation of my line, it means that this point lies somewhere which is not on the line. So let us, for example, assume that this is my point A. Yes? And now I am interested in the line that passes through this point and intersects line L and it's perpendicular to that. So this angle is 90 degrees. And then the point is that I want to have this line to intersect my line, because you know that two skew lines can also be perpendicular. Yes, but this is not going to be the case. I want to write an equation for this line that passes through point A, and I am confident that it will intersect the line L. Okay, so you know that if you want to write an equation for a line in a space, you need to have two pieces of information. One is to have the coordinates of a point that lies on your line. And of course, I have it here. The point A lies on my line and the coordinates are given. Then you need to find the components of the direction vector. A direction vector is a vector that is parallel or, of course, lies on the line that I am interested in writing its equation. So here, that piece of information is missing. I need to look for it. But how can I find that? Okay. So how can I use this piece of information that the line is supposed to intersect my line? Okay, so let us call the intersection point something. So let me call this point, for example, B. We know that B belongs to the line L. So this symbol here means belongs to. Okay? But I know what is happening for this line. I know that every point on this line has coordinates x, y, and z the same. So for example, I can write it in this way. I can say that, okay, x is equal to y is equal to z is equal to some parameter, say s. All of them are the same. And because b lies on the line L, it means that there exists a value for the parameter s. This symbol means there exists a value for parameter s in the set of real numbers such that the coordinates of the point B are s, s, and s, because I know that B lies on L. And then hopefully you agree with me that this vector can play the role of the direction vector for me, vector AB, because it lies exactly on the line. So what I need to do, I need to write the vector AB using the coordinates of the final point and the initial point. So you need to know that I need to subtract the coordinates of the initial point from the final point. Other words, yes, if I want to write this in this form, I can write it like that. Then this becomes S, S, and S minus, then I will have 2, 0, and 1. So finally, my vector AB, which can play the role of my direction vector, is a vector with these components, S minus 2, S, and S minus 1. But on the other hand, I know that AB is supposed to be perpendicular to the line. If it is going to be perpendicular to the line, so a direction vector for this, so if I want to write a parametric equation of that, if I put it equal to t, then it becomes x equal to t, y equals to t, z equals to t. The components that you see here are all equal to 1. So this means that, for example, the direction vector of the line L is something like that. So we don't know exactly where this vector lies. Of course, there is no location for a vector, but I don't know its length, and I don't know its direction. I'm just drawing something there for understanding the problem. But then one crucial thing is that whatever this vector is, it should be parallel to L. And because L is supposed to be perpendicular to L, this means that the vector AB is also perpendicular to vector AD. So I realize that vector AB is perpendicular to vector D. But vector AB is S minus 2, S, and S minus 1. This vector is supposed to be perpendicular to vector D. But what is vector D? As I told you, this vector is 1 and 1 and 1. So this means that the dot product between these two vectors should be equal to 0. So this means that 1 times S minus 2 plus 1 times S plus 1 times S minus 1 should be equal to 0. And from here I can immediately calculate my S. So it becomes S minus 2 plus S minus 1. So this gives equals to 0. So this implies that 3S is equal to 3. And then it implies that S is equal to 1. Okay? By knowing S, I can immediately write the vector AB, which is going to play the role of my direction vector. So AB becomes equal. So this is my vector AB, and now I put S here, so I can find AB is equal to minus 1, 1, and 0. Yes? Now, the equation that I want to write, a parametric equation, or possibly the vector equation here, is 2 and 0 and 1. This is why I'm saying this is a possible equation, because I have chosen this point A, the coordinates of this point. You could have chosen the coordinates of B, because now it's clear, yes, because this is B, and I found that S is equal to 1, so this is 1, 1, and 1. So for example, in this one you can also write 1, 1, and 1. It doesn't matter. So this is one possible answer, and then I will write the parameter t and multiply it by the direction vector. So it is minus 1, 1, and 0. And if I want to write it in parametric form, then it becomes 2 t times minus 1 is the first component. So x becomes equal to 2 minus t, and then the same story, y is equal to 0 plus t, so I just write t, and z becomes 1 plus 0, which is 1. So this would be a set of parameter equations that describes my line. Yes? Okay, I hope that this video is somehow useful for you. The link to the PDF file of this note, you can find it below this video. Until the next video, be safe and goodbye.